Good day, and you're all very welcome to today's technical session of the CNPS with me, Ian Cowan. Today is the solstice, and it's the shortest day in the Northern Hemisphere, so we can look forward to maybe some brighter futures, infinitesimally increasing in daylight time. Actually, this will possibly be the last. Well, it will be the last of these sessions which I'm hosting. I think we will not be starting again until the 4th of January. So a bit of a break for the festive season. Although I think maybe one of Harry's cosmological sessions will be running tomorrow. That will probably be the last before the holiday season as well, which is basically upon us now. But today, we're very glad to have one of our stalwarts, Roger Anderton, talking to us again. And he's actually asked me to host this. So, I have the opportunity now of hosting one of Roger's talks. And it's interesting, actually, Anti-relativity lessons, lesson 1. And I wasn't 100% sure what this was about. I had a very brief conversation with Roger just a few moments ago. I think he's done a couple of videos on this type of subject. We may be able to see one of them presently. But Roger, as far as I can see, I'm just giving my own introductory take on this, and this may be contradicted later. But Roger, as far as I can see, he homes in on a number of interesting points which some of us don't concentrate on very, very much. One is he analyzes the accuracy or otherwise of the translations of various papers. For example, Einstein's original papers in German into English, and is that accurate? And there are a number of translations, and sometimes they've edited them and changed things, and Roger thinks that's important. He thinks we may have been misled in some of those mistranslations, as he would call them. Yes, and the other point that's come out to me in listening to Roger talk in the past is he talks about the inconsistency of sort of relativists in their position, and when you sort of drill down into what they're really saying, they sort of change the basis, or as he calls it, they move the goalposts. So I think he may be alerting to some of those today. And I'm not even sure. Sorry, this is my own take. I may be misinterpreting it, but I thought he may have been a bit ironic in saying, look, this is if you teach this, it's an absurdity, and it'll become patently clear to youngsters who are embarking upon their college career. That was certainly in my case. I started questioning relativity when I was 17, 18 years old. I couldn't understand how A clock could be slower than B, and B, it's total symmetry. In what Dingle has looked at, say, with regard to the twin paradox. I was just told by the professors, look, it may be against common sense, it is against common sense, but just accept it. There's so much evidence for it. And the same with regard to the invariancy of the speed of light, independent of the relative motion of the observer towards or away from the light. That was absurd to me. It was just against common algebra, never mind common sense. So on the other hand, Roger may on the other hand, and he'll explain this in a moment, I don't want to take up too much time, Roger may be developing a set of lectures that he would like to give to youngsters embarking upon a physics career at third level. That may be what he's on about. So we'll soon find out. And I think he has a video and he has slides, and I think he'll be able to press all the buttons because he's a dab hand. In fact, he has administrative permissions with this system, so I'll not be tasked too much to do things. So Roger, I'm going to, let me just see, is everybody here? Yeah, okay. I'll have to paste the, you're up now, Roger. And
thank you.
Yeah,
yeah.
It's uploading. So you know the score as well as I do. I mean, you host the alternative meetings. So I'm going to bring myself down. You'll have the floor, and if you want me to put anything up or down, just call. You can do it yourself if you wish. In fact, you probably prefer that because you have all the
No, I can't.
facilities.
I think
Okay,
I'm not.
no, you can't now. Well, just
I'm
tell
a guest.
me, but you put these things up already. So tell me when you want the video or tell me when you want the slides and I'll pop them up, okay? And if there's any problem, I'll come back. But apart from that, I'm going to leave the floor entirely at your disposal.
Cheers. Hello, everybody. Merry Christmas. And thank you for joining me. If you're on for your festivities at the moment. So the point of these videos that I'm making is that we people that are anti-relativity or think relativity is a lot of nonsense. We don't really increase in numbers. It's whereas the people who believe in relativity keep increasing in numbers, and the reason is because they keep bringing in a new generation of students. They keep teaching a new lot of students relativity. And the point is that I want to go through some of the things which they're teaching these students as relativity and pointing out it's a load of nonsense. So the purpose of anti-relativity lessons is to point out what's being taught in relativity lessons is a load of nonsense. And the first one I'm going to start with is sort of like an introduction. It's a light introduction to the subject. So hopefully students might be more open-minded when they go through their physics education process. They can then look at these videos and say, well, I've been taught relativity, but this anti-relativity lesson is going through the same sort of things as I've been taught and is pointing out what those things are as a load of nonsense. And the students that are being taught physics, they're told to teachers, and so it just perpetuates. You get more and more people believing nonsense. They're just told to accept it. So the anti-relativity lessons is to point out that no, don't accept the nonsense they're telling you in these physics courses. So if I can, please, Ian, can you upload my video, please? Put the video on screen. Yes, thank you. So this is, I've videoed, done my first video on anti-relativity lesson, which is my introduction. So I'll just leave it to this video to go through the main point.
So shall I start it now, Roger?
Yes, please.
Yeah, okay, it's 28 minutes. I pay the lot. Okay.
Thank you. Maybe it's me who starts it.
You have to start it. Yeah.
It started?
Doesn't seem to.
I start it. It's probably my end.
Yeah, it is.
Hello,
Thank you.
These are anti-relativity lessons, starting with lesson 1, which is an introduction. So there are lessons in special relativity, and the aim here is to try to counteract that and give lessons in anti-relativity. And the way to do that is to point out what is being taught in relativity lessons is nonsense. Over the years, the teaching of special relativity has been to pile on more nonsense. So going to contrast how that teaching has changed. And take an example that what was said in the 1982 relativity book with what was said later in the 1991 book when the book was updated. So the example I'm going by is this person, Wolfgang Rindler. He's a physicist and he's written quite a lot on relativity. And I'm comparing these two books by Wolfgang, one published in 1982 and the other one published in 1991. So the 1991 is the second edition, where he's updated what he's saying in 1980 from what he was saying in 1982. So I'm going with the second edition of the book and pointing out when different to the first edition. So the aim of this is to show the method of teaching relativity is to move the goalposts. Some nonsense is said, but that is never enough, and some extra nonsense then gets added later. Moving goalposts is making changes is supposed to be a fallacy, but believers in relativity seem to treat it as a virtue to do that, or they just keep making changes to what they claim. This was in the preface to the first edition of the book, and it says, apart from being a vehicle for communicating my joy in the subject, that's for special relativity, this book is intended to serve as a text for an introductory course on special relativity, which is rather more conceptually and mathematically than experimentally orientated. In this context, it should be suitable from the upper undergraduate level onwards, but the book might well be used autodidactically, as means from self-study by a somewhat more advanced reader. So the book is intended as being used to teach relativity. In the second edition, it has this. And this is the preface to the second edition. The aim of this second edition is the refinement and improvement of the text, as well as the incorporation of new data and ideas. The most radical changes are to be found in a novel and particularly careful derivation of the Lorentz transformation, and in a somewhat different logic for the development of continuum mechanics. In connection with the former, I have returned to the primacy of Einstein's relativity principle as opposed to Dixon's principle of uniformity. For inertial frames, lesser changes have been made on almost every page, and many paragraphs and even more sections have been rewritten. Over 20 new exercises have been added, and I'm not going to deal with the exercises. I'm just going to deal with what he's saying. And he also points out there's a new notation being used and so forth. So the second edition has amended what's been said in the first edition. So now diving straight into chapter 1. So chapter 1 is on the foundations of special relativity. In section 1, its introduction, and says one of the greatest triumphs of Maxwell's electromagnetic theory, and that was in Syria 1864, was the explanation of light as an electromagnetic wave phenomenon, but waves in what? In conformity with the mechanistic view of nature then prevailing, it seemed imperative to postulate the existence of a medium, the ether, which would serve as a carrier for these waves and for electromagnetic stress in general. This led to the most urgent physical problem at the time, the detection of the Earth's motion through the ether. So, and the problem of the ether, which is the medium for light waves, we will keep coming back to. The book continues, of the many experiments devised for the purpose, we shall mention just 3. Michelson and Morley looked for a directional variation in the velocity of light on Earth. Fizeau, Muscat, and later Lord Rayleigh looked for an expected effect of the Earth's motion on the refractive index of certain dialectics, and Troughton and Noble try to detect an expected tendency of a charged plate condenser to face the ether drift. All failed. The physical explanation that the Earth might drag the ether around was with it only led to other difficulties with the observed aberration of starlight and could not resolve the problem. And so what I say is the way the relativists, those who believe in Einstein's relativity, interpret experiments, I dispute, but we'll pass on that for now. So the book continues. In order to explain nature's apparent conspiracy to hide the ether drift, Lorentz between 1892 and 1909 developed a theory of the ether that was eventually based on two ad hoc hypotheses: the longitudinal contraction of rigid bodies and the slowing down of clocks, time dilation, when moving through the ether at a speed v, both by a factor, open bracket, 1 minus v squared divided by c squared, close bracket, to the power 1 divided by 2, where c is the speed of light. This would so affect every apparatus designed to measure the ether drift as to neutralize all expected effects. And for that he gives footnotes. The footnotes are to indicate that Fitzgerald proposed longitudinal contraction of rigid bodies and Einstein proposed time dilation. Time dilation is slowing down a clock, so is really clock dilation and not an effect on time. So calling it time dilation gives the wrong impression as far as I'm concerned. Students are being deceived that time is affected. Another thing to note here is the speed of light. C is supposed to be in vacuum, free of the influence of fields, but that wasn't mentioned. The book continues in 1905. In the middle of this development, Einstein proposed the principle of relativity, which is now justly associated with his name. Actually, Poincaré had discussed essentially the same principle during the previous year. So my comments are: it's good of the book to admit that Poincaré talked of relativity principle before Einstein, because some texts don't even mention that. But the book does not go into details of contrasting what Poincaré says with what Einstein says, so it does not give different perspectives on the principle to let students know what they think is best. Not contrasting Poincaré with Einstein is typical approach to such relativity texts, so leave the students poor in only giving them one point of view anyway. The book dismisses Poincaré's viewpoint on relativity principle by saying the following: but it was Einstein who first recognized its full significance and put it to brilliant use. And the book doesn't explain how. And it's, as I know, it's the usual tactic of relativity texts to make claims and not give sufficient explanation for why they made those claims. So it's making a claim about Poincaré not dealing with relativity principle sufficiently, and it's not saying how. Book then says he elevated the complete equivalence of all, this is Einstein, of all inertial reference frames to the status of an axiom or principle for which no proof or explanation is to be sought. So my comments are, in other words, wants student to accept / believe the relativity principle without evidence. Later it will be found that it does not make sense, but students expect to believe it regardless. This is why critics of relativity often accuse Einstein's relativity, of being a religion, because students are asked to believe something as a matter of faith, just like a religion. The book says, on the contrary, it explains the failure of all the ether drift experiments, much as the principle of energy conservation. It explains a priori, i.e., without the need for a detailed examination of the mechanism, the failure of all attempts to construct a perpetual motion machine. And my comments are, once again, a claim is being made without giving explanation as to how. I have read nothing that makes sense of how relativity principle can explain failure of ether drift experiments, but making an unsubstantiated claim is not good enough and wants to throw up a diversion of perpetual motion machine. Does not go into explanation about that as well. And then the book moves on. Book says, at first sight, Einstein's relativity principle seems to be no more than a wholehearted acceptance of the null results of all the ether drift experiments. And my comment is yes, but no reference is being given as to whether this was what Einstein intended, and continues to throw out claims without any substance to back them up. So book says, by ceasing to look for special explanations of those results and using them rather as empirical evidence for a new principle of nature, Einstein had turned the tables. Projections could be made. And so my comment, another claim without substance, is that how science is supposed to be done? Sounds like Einstein supposedly assumes what experiment shows, putting aside the issue that I object to that interpretation of experiment. So the book carries on to say, the situation can be compared to that obtaining in astronomy at the time when Ptolemy's intricate geocentric system corresponding to Lorentzi's ethocentric theory gave way to the ideas of Copernicus, Galileo and Newton. So my comments are, I don't see how. The book once again doesn't go into sufficient explanation. And so what my comments are, in the case of the Copernican revolution, the existing theory was of a geocentric theory, where Earth was centre of motion and sun, planets, etc. moved around the Earth. With the revolution came the sun-centred theory that the sun was centre of motion and Earth and planets moved around it. But what came out of that revolution was, could use different coordinate systems, could have a coordinate system of Earth as centre or Sun as centre, or any other centre that one liked, such as the barycenter. So if it was like that revolution, then the ethocentric was still valid. Anyway, the book carries on and says, in both cases, the liberation from a venerable but inconvenient reference frame ushered in a revolutionary clarification of physical thought and consequently led to the discovery of a host of new and unexpected results. And so my comments are, inconvenient reference frame, but still valid. Ethocentric might be inconvenient, but it's still valid, and then ether is still valid. Book continues. Soon the whole theory based on Einstein's relativity principle and on a second axiom asserting the invariance of the speed of light was in existence, and the theory is called special relativity. And my comment is, which we will get to, but what has been said so far has not made sense. Expectation of the student is to hope that as the relativity lesson continues, it will make sense, but it doesn't. So the book goes on to say its program was to modify all constraints on all the laws of physics. And my comment is, and of course the relativity text will not explain what all these laws of physics are and how they were modified. So once again, it's just making claims. As you read in the book, it's just making claims, not explaining anything. You're hoping eventually it will start explaining things, and it doesn't. But then carries on to say, for Einstein's principle is really a method principle. It puts constraints on all the laws of physics. And then my comment is, but does not explain what a meta principle is, and is using the term meta is suggestive, is that talking about metaphysics, in which case talking about metaphysics is not physics. But by this stage, the student is probably starting to give up trying to make sense of it all. But carries on to say, the modifications suggested by the theory, especially in mechanics, though highly significant in many modern applications, have a negligible effect in most classical problems, which is of course why they were not discovered earlier. However, they were not exactly needed empirically in 1905 either. This is a beautiful example of the power of pure thought to leap ahead of the empirical frontier, a feature of all good physical theories, though rarely on such a heroic scale. So my comment is not worth responding to with anything more than that has already been said in the earlier comments I gave. And so the book continues and says, today, over 80 years later, the enormous success of special relativity theory has made it impossible to doubt the wide validity of its basic premises. So my comment is, in the first edition, it said 70 years, but second edition, it's about 10 years later, so the update is to say 80 years. And of course, I dispute the success and think it was more of a mess. The book says it has led, among other things, to a new theory of space and time, and in particular to the relativity of simultaneity and the existence of the maximum speed for all particles and signals, to a new mechanics in which mass increases with speed to the formula E equals mc squared, and to de Broglie's association of waves with particles. And I dispute all of that. And one of the easiest things to dispute is the mass increase. So physicists like this one, Don Lincoln, says there is no mass increase. So have a disagreement among relatives, some saying there's mass increase and some saying there isn't, i.e. they can't agree on the theory. The book I'm going by, Wolfgang, he's saying there's mass increase, and you've got these other people saying there isn't. So somebody's got it wrong. So the book now goes on to say, one of the ironies of these developments is that Newton's theory, which had always been known to satisfy a relativity principle within the classical framework of space and time, now turned out to be in need of modification, whereas Maxwell's theory, with its apparent conceptual dependence on a preferred ether frame, came through with its formulas intact, in itself a powerful recommendation for special relativity. So my comment is another collection of claims that will be adequately dealt with anon by the text. Book says, apart from leading to new laws, special relativity leads to a useful technique of problem solving, namely the possibility of switching reference frames. This often simplifies a problem, for although the totality of laws is always the same, the configuration of the problem may be simpler, its symmetry enhanced, its unknowns fewer, and the relevant subset of physical laws more convenient in a judiciously chosen inertial frame. And I'm going to pass on that. Book says, our main concern in this chapter will be to set Einstein's principle in its proper perspective and to derive from the so-called Lorentz transformation equations, which are the mathematical core of the special theory of relativity. With their help, we can subject the various branches of classical physics to the test of Einstein's principle, and with their help to find the necessary modifications where the principle is not satisfied. And we're going to be getting to that at the moment. This is the end of section 1, and we're now moving on to section 2. So this is what is said in section 2. Schematic account of the Michelson-Morley experiment. And it says, certainly the most famous of all the experiments designed to measure the ether drift was that due to Michelson and Morley, first performed in 1887 and repeated many times thereafter. Its essential principle was to split a beam of light and then to send the two half beams along orthogonal arms of equal length, at whose ends mirrors reflected the beams back to the starting point where they were made to interfere. Then the entire apparatus was rotated in the plane of the arms. If this causes a differential change in the to and fro light travelled times along the two arms, the interference patterns should change. Suppose originally one of the arms marked length L1 in figure 1 lies in the direction of an ether drift velocity v. Figure 1 should make it clear that the respective to and fro light travel times along the two arms would then expect to be the following equations. And we're going to get to figure 1 in a minute. This is figure 1. The respective to and fro light travel times along the two arms would then expect to be the following equations. And we're going to get to figure 1 in a minute. This is figure 1. And these are the equations for the times taken. So it says where L1 and L2 are the proportionally equal lengths of the two arms, since T subscript 1 doesn't equal T subject 2, a rotation experiment through 90 degrees should produce a shift in the interference fringes. None was ever observed, which seemed to imply V equals 0. Yet at some point in its orbit around the Sun, the Earth must move through the ether with a speed of at least 18 miles per second, its orbital velocity, and this should have been easily detected by the apparatus. Of course, in Einstein's theory, this null result is to be expected a priori. Light propagates in all inertial frames and thus also in a laboratory speeding through space, just as it would in still ether. It is not for us to ask how. So my comment is going to look at the last thing said. First, this bit, it says, of course, in Einstein's theory, this no result is to be expected a priori. My comment, meaning it's assumed, is not predicted by theory, it's assumed by the theory. And next, the text says the following: light propagates in all inertial frames, and thus also in a laboratory, speeding through space, just as it would in still ether. And my comment is, which immediately raises the question of how. Suddenly have the mention of ether, and that would be problematic as go further on. So an alert student would ask the question, how? And so next the text says it's not for us to ask how. And my comment is, this comment has been added to the second edition. It was not said in the first edition. What I imagine is students were asking him how. How is it possible? All he's just said. And his answer to that question is, don't ask that question. Indication that it was all nonsense. So here ends today's lesson with pointing out relativity lessons don't want students to ask how questions. More will follow with lesson 2. But for the time being, finish the end. Thank you.
Hello, I'm back again. Cheers. Can you put me back? Right. Hello, Ian. Okay.
Sorry, I wasn't live.
Okay.
Your video's not on, I think, Roger. We can hear you, but we can't see you.
Hey, I'm back again.
So,
thank you.
I'll leave you now. Do you want me to put the slides up, or you can tell me when you want those up?
We could put the slides up. Thanks, please.
Okay, I'm going to put the slides up, and I'm going to disappear then.
In what way are you disappearing?
Well, it means I just bring myself down, so I'm actually mute. But I can hear everything, and when you need me, I'll come back. But you can probably move on the slides yourself without me.
Okay, is there anybody in the green room?
Very few. There are 2 actually. There's only Denny and James.
Yeah.
Why do you ask? Do you want them to have a word now, or do you want me to wait till the end?
Well, if there's any questions.
Yeah. Well, so I think we only have gentlemen today. As I always say, I think I omitted to say it earlier on, but it is possible to interrupt and ask questions during the presentation. But we normally like to leave it to the end. But as Roger has his presentation in 2 parts, really a video and then slides, perhaps there is an opportunity now to come in with specific questions or comments with regard to the video. I'm not sure if we have many people in the social media. I've only had maybe 2 comments coming in. But if you'd like to post a question, we can do that. Now, Denny, I can't see him at the moment, and Jim Keane, I can see him. Well, maybe I'll bring Jim up at the moment. Jim, have you anything to say now, or would you like to wait till the end?
No, well, I just joined a short time ago, and I don't have any questions right now, but thank you for asking, sir.
Okay, well, thank you very much. And by the way, I did post the direct link into the comment. I don't know if that's how you got in a bit late, because I think some other people were having problems. Anyway, you're here. So we'll come back later.
Okay.
Thank you, Jim. Denny, would you like to say anything at this stage, or would you like to wait till the end?
Well, you have your own theory based on Hertz's equations rather than Maxwell's equations, which is what Roger was talking about. Maybe you should say something about that, Ian, because if you're right, then special relativity falls apart.
Right. Well, I mean, I find it interesting that Roger is looking at it from this sort of logistical point of view. He's looking at Rindler's books, which I have studied, and he's, sort of analyzing the statements he's made, maybe bland statements. He's following them up, Rindler is, with mathematics, but Roger is sort of picking holes in them and looking at the strict analysis. You're coming to the point of view that it seems a bit odd, So what I think Denny is referring to is I come at this from another angle, and maybe I get similar results. I don't accept the Lorentz transforms, and I don't accept Lorentz ether theory. I don't accept the Lorentz transforms. I think they work because they're really a quick fix. A quick fix to a problem that hasn't been adequately addressed. To wit, the fact that if you're looking at Maxwell's equations as they're originally written, maybe in the 1860s or perhaps 1873, when the complete books were written, you get a sort of a partial differential with respect to time in respect of the electric field intensity and the magnetic induction and so on. Now, this actually is at variance with how we analyze hydrodynamic phenomena. In all other spheres or aerodynamic phenomena, when we're looking at movement of fluids and so on. And what we do is we use a total derivative or a convective derivative. I think that's what Denny is talking about.
Yeah.
We've talked about. So if you like to call them Maxwell-Hertz equations, I mean, taking the Maxwell equations, but substituting the complete derivative, the total time derivative, which is basically delta by delta t of the function plus the velocity, if you like, the dot product of that with the gradient operator. So that's basically, it's a well-known phenomenon. It's called the convective derivative. Now, I claim, and I think Denny, you I don't know if you totally accept this, but you're very sympathetic to it. That's the problem. You can transform correctly from one equation to the other using the Galilean transformations. And hey, presto, you've solved the problem. So basically, I feel that these contradictions are occurring because you have, in Maxwell's equations, omitted to include this convective term. And therefore, you need to introduce these ad hoc, gamma functions to take account of the lack of including that very essential term, which is dependent upon the velocity of motion through the medium. So, okay. So I don't know, Roger.
You also maintain that the velocity of light is not independent of everything. It's and you even suggest an experiment to resolve.
Yeah, we discuss a number. So, I'm not sure exactly what you're referring to, but yeah, indeed, that follows, I dare say. Well, let's put my cards on the table a little. I mean, I'm an etherist. A person might say that because
there has to be a medium.
There has to be a medium if there's something waving. If you accept the wave motion of electromagnetic waves, analogously to sound waves or water waves, and those are medium. So let's call it an ether. Well, actually, we know the properties of the ether. We don't know basic properties like density and so on. Well, they've been postulated, but we're not sure. But we know the electric properties of the ether, the electric permittivity, magnetic permeability, and we know the characteristic impedance and so on. And we know the speed of light, which is basically just the Newtonian composition of the, stress and strain, which is related to the electric and magnetic. So we get C is 1 over the square root of epsilon naught mu naught. Yeah. Well, it follows. I mean, the Doppler equations, if you like, you just use the classical Doppler equations, which are used for sound, and therefore you find that if you're in a medium, and if an object which is emitting sound is moving in that medium, be it a police car siren moving through the air, or a light emitting piece of apparatus moving through the ether, or indeed, if you wish, a stone moving through the water on the surface of a pond. What actually happens is that the wave is created in the medium, and therefore it has a constant speed. So the velocity of the source does not actually alter the velocity of the wave. Yeah, that's, if you like, that's the second postulate of the special theory of relativity. But so what, I say, that's true for all motion. However, SRT says there's complete reciprocity. So if the police car is stationary in the air, or if the light emitter is stationary in the ether, and an observer moves towards the stationary object in the medium, or he moves away from it. Well, what it says, it makes no difference. You have, the speed is still the same. But the classic Doppler experiment says no, the speed varies. The speed varies and the frequency varies. But the wavelength remains the same. So therefore, the heresy, which I think Danny's referring to, which I've talked about and I've written about, is no, the speed of light is certainly not constant, and we have a lot of experiments to establish that. So I would maintain. So is that the main point that you were referring to, Danny?
Yeah.
Well,
Yeah.
it's a whole different point of view. It's more rational. It meshes with hydrodynamics and aerodynamics and whatnot.
Right.
But they won't consider it because anyone that steps out of line gets canceled. So you were working for the National Bureau of Standards of Ireland, so you couldn't really be fired for it. But you didn't. I guess you said, and when you gave your when you were retiring, you gave your talk, you decided not to make a point of this and just let them go on believing what they wanted to.
Yeah, well, I put my head above the parapet to a certain extent when I produced the first paper, which was published in Galilean Electrodynamics in 2003. And I put my affiliation in the standards body. I did do that. But I'm retired now. So, I mean, I don't think they cared too much about me. They probably wouldn't have wanted me to start going onto the media and saying everybody was wrong. That might have been a bit too much for them. But I didn't really understand what I was saying. But I'm completely a free agent now. I can say whatever I want. I know and if I write anything, I just put my private address.
I know, that's the way it is nowadays. For example, Will Happer, a physicist, professor emeritus at Princeton University, got up in front of Congress with a colleague from MIT and said that climate change is nonsense. The the people who have these models, the models don't predict the right answer, and so it's the whole thing is a scam. They said, no, okay, very well. Now we'll go on to the next person. It was, it had no effect because the climate change people have the money and they have the power, and they aren't listening. They don't really care what's true. They care about the money. So yeah, I'll bet if you were while you were still working, if you had stood up and said these people are all wrong and they're scammers and everything, you would have been in big trouble probably with your boss.
You're probably right. I mean, the nearest I got to that sort of feedback was jocular conversation over the coffee table. And I remember one of the heads of department, he wasn't my direct boss, but he was like a relative. He said, "Oh, Ian, if something is black, you say it's white, and if something is white, you'll say it's black." So I just said to him, well, if the majority of the people say that something is black, you will always say it's black. You won't even question it. I will always question it.
Yeah.
And of course, what you've said is very true, Denny. And these conglomerates with the money and the power and the influence and the media influences on are actually succeeding. That they're convincing people and making them believe things without thinking. However, for an analytical person, their operations are counterproductive. I mean, for my part, if I may say so, once I hear, doesn't matter what the subject, that this is a proven science and you cannot question it, and all the experts agree, as they're doing for climate change, you could mention 20 other different things. You could mention hundreds of other things. Well, then I know that there's something wrong about it. And you're a denier if you question it. Then I know there's something wrong about it, and it's a very, very weak basis.
Yeah, that's right. It's sad but true. Yeah.
So thanks very much for those comments, and I think we'll have opportunity at the end to come back to this point, because it's great that Denny has raised a point that maybe some of my humble thinkings are working in a parallel way to yours. But I'll let you go on now, shall I, Roger?
Well, I was concentrating on the education system and what they teach people for when they're teaching relativity, and they don't really go into sufficient detail on things. They just sort of make claims and they don't back it up. And so the issue of ether, they do bring up this book, which you're supposed to learn relativity from Introduction to Special Relativity. It does talk about the Michelson-Morley experiment and so forth in terms of an ether, but it doesn't then give you sufficient explanation upon that. It sort of says this: light propagates in all inertial frames, and thus also in a laboratory speeding through space, just as it would in a still ether. So it is prepared to mention ether, and often these relativity books are not prepared to even say that it's talking about there maybe be a still ether in this context, but it doesn't give sufficient information then about that. And so then a student might say, well, please explain that in more detail, and it immediately responds, well, it is not for us to ask how, exclamation mark. So it tries to cut down that conversation immediately. It's sort of like, well, but go back to this question of still ether, and it needs more explanation, but they're not going to give it. They just are giving a very dumbed down education system on relativity. It's just the student ideally should be asking questions, but then they're just going to try to stop that. They're just going to say, you've got to accept relativity, even though it doesn't make any sense. And if I could Ian, if I could upload something else from YouTube.
Can you do it, Roger, or do you want me to do anything?
I'll put another thing on. So, yeah.
Shall I bring your slides down now? Shall I bring
the
slides
down, please, and share this other? And there's this other screen I'm putting up. Can you? Oh,
is that it?
Yeah. Can you share this other screen now?
Well, I've put something up that I thought you've just posted, but
yeah,
that's it.
Great. Thank you. So,
okay, I hope we can read it. I'll just appear now. And I'll try to maximize it by getting rid of your photo as well.
Yeah. So, if I go up to the top, so this is a very interesting site. It's from the University of New South Wales, Sydney, Australia, and it's teaching Einstein's relativity. They call themselves Einstein's light. And so it's giving a lot of information about relativity. And so it then gets on to a section after teaching about relativity and so forth. It gets onto this section which says, how weird is the invariance of the speed of light, ? Is the principle of special relativity really counterintuitive, ? And so it's having these people that are moving around, and it's calling them, I'm a bit of a problem here because of moving things around. Get back to it. We're going down. They've got these people, Zoe and Jasper, moving around, and they're comparing observations and measurements. So if I get down to the relevant section, light, electromagnetic waves and the logic of relativity. And it carries on. If I can find the right thing, it says here. So I think that's it highlighted there. So if that's clear at the top there, it's saying, I'll read it out. After talking a lot about relativity, it suddenly gets to this part, and it says, at this stage, many of my students say things like, the invariance of the speed of light among observers is impossible, or I can't understand it. And so the teacher, lecturer, professor has been teaching relativity to them, and eventually they get to a stage where the students are saying what's being told them doesn't make any sense. And so the response from the teacher is, well, it's not impossible, it's even more than possible, it's true. This is something that has been extensively measured, and many refinements to the Michelson and Morley experiment and complementary experiments have confirmed this invariance to very great precision. So it's claiming what sounds impossible has been proven by experiments. But of course, I dispute that. I think when you're talking about experiments in terms of a theory that doesn't make any sense, you're then talking about those experiments in terms that don't make any sense. So I dispute that those experiments have shown what they claim. And at this point in the teaching of it from the university, it's not explaining how those experiments should be interpreted by the theory. But he carries on and he says, as to understanding it, there isn't really much to understand. However surprising and weird it may be, it is the case, it's true in our universe. The fact of the invariance of C may require some acceptance, but it doesn't take much understanding. What requires understanding are its consequences and how it can be interpreted in what we already know. So it's just telling the student to believe it. Even though it doesn't make sense, the student is expected to believe it. And it's sort of like, well, if you're doing that, a student can believe nonsense if it is accepting relativity if you haven't got a decent explanation. So that highlights again what I'm saying, that they don't go into sufficient explanation of how this nonsense can be true. They just tell you to accept it. And that's the whole problem with teaching of relativity. Students eventually are faced with either you accept it or you have to just give up doing the relativity course. And if you accept it, well, you're just going to talk nonsense. You're going to say things which are nonsense. You're going to talk about a theory which is nonsense. And you're going to talk about experiments in terms of that theory, and that what you're then saying about that theory is nonsense as well. Your interpretation of the theory is nonsense. And that's the whole problem with relativity. And that's what I'm trying to point out in this anti-relativity lesson, that it is kind of like a brainwashing in relativity lessons to try to get you to believe nonsense. It is not a proper science at all. If you were doing proper science, at least it would sort of like tend to make sense. But in relativity, it doesn't make sense. And the only thing they got to offer you is you got to accept it regardless. So hence my whole disappointment with the physics enterprise. So if you come back here, please, thank you. That was the point I was trying to make from this bit. It's not just this book, which I've got here, Introduction to Special Relativity, not just this book, which tells the students to believe nonsense. It ends up as pretty much what they teach in relativity lessons to the student. Just accept it, even though it may sound nonsense to you. Thank you. Could come back in. Can you come back?
I wasn't sure
Okay.
if you wanted to come back.
Thank you.
Do you want me to engage in some conversation now, or are you completing this formal part of the lecture?
That was the point of this lesson, and as you go through the book, this book here, as you go through the book, it's just piling more and more nonsense on top. So I don't know whether it's worth going on with further lessons if it just starts off at nonsense and this then wants to pile on more nonsense. What would you say to that? Sorry.
Yeah. Well, I mean, it's extremely interesting to make these points, but I'm always amazed how, if this is so much nonsense, and much of it is, I dare say, how it's actually got through to be orthodoxy. I mean, there are other subjects maybe which are being taught not totally objectively. Maybe history would be one example, or politics or economics or something. But I mean, they aren't as blatant as this. If what you say is so, Roger, there's a blatant. I mean, maybe it's religion. If you're teaching a particular religious doctrine, well, even that, they'd be teaching the doctrine rather than just putting in non sequiturs, which would, be illogical, but something that you couldn't contradict. So how come that in this particular subject, this theoretical physics or whatever, over the last 100 years in particular or more, we've got to the stage that we're just teaching nonsense all the time, in your words, and if there's any questioning, which probably any bright student on first being exposed to this would and must, raise questions, that they're just quashed, and then in later life you put those into the back of your mind, and you accept these. I mean,
Yeah.
we do sometimes see that in some of the reactions to our own views here, our own dissident views.
Thank you. Yeah, I have looked at religion was basically Christian religion, and you can look at the Bible and say, well, things don't really make sense in there. You're asked to believe that it's one God, but then there's God the Father, there's God the Son, and there's the Holy Spirit, and they're all gods. So somehow or other, 3 different gods become one God. So you can start scratching your head over that. You say, well, how can that be possible? There's things in the Bible where you sort of like try to make sense of what's being said, and it doesn't really make sense. And I think there are people who look at that and they get disappointed, like myself, and then they go over to science. And over to science, well, it's supposed to be you experimentally test it, you make observations and so forth.
Yeah, that's the point.
And you think, well, that's good. You can actually test what's being said. But then they're doing these experiments for relativity, and then they're just making false claims that the theory is supported by experiments. So they managed to cut that out. That was the big difference between science and religion. Science is supposed to test by experiment, but they suddenly dictate what the experiments are showing. And so you can then put a nonsense in as a theory for those experiments. And so science just ends up the same as religion.
But it seems a bit easier for me, at any rate, to understand how these restraining mechanisms might arise in theology or philosophy or even social science or economics, where people want to believe a certain doctrine. Where, like, for example, in the social sciences, it might be a left type of thing versus a right type of thing or whatever. But here, it's meant to be totally objective. I mean, what's the advantage in propagating a manifestly incorrect theory? You're not emotionally invested in it, only insofar as you have accepted it for a number of years, and then you don't want to reject views that you've put your all into.
Yeah.
There were some comments from James here, Jim Keane. He's saying, "What is orthodoxy?" I have a comment. We need to target students. The false God is the theory that space and time are continuous. Well, I know that's one of Jim's points. So, Jim, I'll bring you back, maybe, if I may, just to elaborate on those brief points you put into the comments.
Hi, Jay.
So it's Jim Keane here.
Yeah, well, to explain why this is orthodoxy, this special relativity is consistent with the theory that space and time are continuous. And so, again, we have the usual suspect being this idea of a space-time continuum and so forth, which is always there. And so that one explanation for the orthodoxy might be to maintain this false idea. What I maintain is a false idea.
The mainstream do admit, if you go to the quantum level, when you get down to the subatomic, things do start to break down and they're not continuous anymore, discrete. And so they admit that relativity sort of has problems at that level. But on the
I question that. I don't think that's a correct statement, Roger. They are firmly in the camp of continuous space and time. There is this loop gravity theory that claims that maybe there's some discreteness or some kind of foam of space at distances less than the mythical Planck length, but that's a minority point of view, and it doesn't include all three, the trifecta, which is space, time, and energy quantization, or what I call full quantization in binary mechanics. So that conventional quantum mechanics is really, really squarely in the camp of favoring and upholding the idea of continuous space and time, which means that you have to explain what's going on at every point in space. And since you're using real number position coordinates, it means an infinite, in any volume, no matter how small, there's an infinite number of points. And so that you get into this whole magic or miracle realm that somehow, at infinitesimally small things exist, which really couldn't exist. And so, it's talk about a mess. There is your mess. And so special relativity is a subtopic in that mess.
So
comment.
One could certainly argue that the genesis, of some of the acceptance of some of these theories could be along these lines. But, the situation we're in now, for example, Professor Buneb, who actually will be speaking to us next year, has said, for me, the reason why this nonsense is reached is because there is economic interest in teaching this nonsense. This is why we need to find economic interest in teaching real science. So be interesting to see. Yeah.
They're stuck in a rut of teaching relativity. I've gone to several relativity courses, and they are just stuck in the rut of teaching the same sort of nonsense, which they've been teaching for probably about 100 years now. And then I'm not aware of quantum foam being a minority point of view. I saw one of the ways when they're teaching relativity is to get out things on the subatomic is to dismiss that as a subject being dealt with in quantum physics. So you're looking precisely at relativity, which is a continuous thing, and anything which is, so say, outside of that is another subject, and the other subject being quantum physics.
Just one other point. I noticed coming in here, Kurt Renshaw said, maybe disputing the earlier points I made and Denny about the necessity of a medium, and you concurred with. The wave one itself is just a way to relate light's interaction with other things. It is not a wave in the sense that it needs a medium. Well, that's one view.
That view doesn't make sense. I mean, the whole examples we have, like water waves, that needs a medium. It's the water. Sound waves through air. The air is the medium. It's sort of like every wave we know is really wave in a medium, and so you would sort of like building upon that way of talking about waves, you say, well, light would need a medium as well, and suddenly they're saying no, light is a wave, but it doesn't need a medium, and it's sort of like it's non sequitur. It doesn't follow that there's no medium.
Yeah.
Just from saying that.
The SRT developed special equations for the Doppler effect with light, which are quite at variance with Doppler effect of
but with that book, as I mentioned, it does sort of bring up the issue of ether, but then it suddenly says don't talk about it. Effectively says don't talk about it. It's suddenly it's not going into sufficient explanation on it. It just brings it up and says you shouldn't ask.
My worry, coming back to Denny's earlier points, is when something becomes prohibited, from even conceptualizing. And I think I told you of an anecdote where some research student actually mentioned to me, I've no validation of this, but he said one of his professors in one of the universities privately admitted to him that he did conceive of some sort of ether, but he said he daren't mention it because it was as good as his job was worth. So Jim, is that all for the moment? And can I bring you down? Thank you very much for that.
Yeah, well, in terms of the economic impact, just one quick point, if I may.
Okay.
more. The discussion a few moments ago raised what the economic impact or relevance might be. And what I've been trying to do in binary mechanics is to point out that it does provide new technology, which can be very, very useful. For example, if the basic postulates of binary mechanics are correct, of course, we can cool things down to absolute zero in a simulation and observe what happens. We can't really do that in the real world. So that represents a technological advance. Also, my second and last point that I'll mention with respect to new technology, which might be economically important, is the tremendous advance in resolution, both spatial and temporal resolution. Right now, the standard technology is pretty much in the electron microscope level, but using the binary mechanic lab software, one can obtain a resolution many orders of magnitude smaller in terms of studying the micro events that occur and underlie the various processes. And finally, the second aspect of increased resolution is increased time resolution. So that for things like, for example, cesium-133 changing states and being useful, therefore, as a clock, this whole process of the cesium atom changing its structure basically periodically and forming a cesium clock can be studied frame by frame, much like a video can be analyzed frame by frame at many orders of magnitude greater resolution than currently available by any other technique or methodology in our laboratories. And so that binary mechanics does indeed offer possibly economically viable advances in technology. And I'll leave it there as a point because you all raised the point about, the economic factor and how that may be important in changing views. Well, a lot of the technologies that we have now today are not necessarily entirely understood, like even electron microscopy is not exactly totally understood, and yet it is used as a tool. So binary mechanics, basically, my summary statement then offers some really astounding technological advances, which can be economically very, very important. Thank you.
Okay, well, thank you very much for that. And following on from Jim's point and points made by Professor Boutia, and maybe summarized by Cerna. He's a Spanish speaker, but he says the money, it's an unbalance for sure in physics and around the world. So, is there any, binary mechanics would be one maybe avenue, but is there any possibility for dissident organizations such as a CNPS to encourage the teaching of physics, what we would call critical physics, and to make it economic for people to do that? If economics is at the bottom of the acceptance of all this nonsense, that people realize that if they teach this nonsense, as we say, they're going to have a very easy life and they're going to make a lot of money. But if they do the opposite, they're going to suffer. So while you're thinking of that, Roger, I'm just looking at the green room. Yeah, actually, Denny, I've just scrolled down. If you've had your hand raised for a moment, I apologize. I've only seen it just now because I was looking at one or two other people who've joined. So, Denny, you're up again. What's your response to any of this?
Well, I don't think economics is necessarily at the basis of, as I think you suspect too. It's a matter of, it's really a spiritual matter in that, is it all right to lie to get ahead or not? Or should you, one of the 10 commandments is don't bear false witness and so on. I see, the physics going downhill nowadays, and because things like the Ten Commandments, which used to be very, very important because the Western civilization was very Christian, are now viewed as superstition, and you shouldn't pay too much attention to it. Well, how has this worked out? Well, for example, on the internet, what you see is scammers everywhere, because it says in the Ten Commandments, "Thou shalt not steal." That's just superstition. You've got to get ahead. You've got to have the good life, and you shouldn't have to work hard at a job you don't like. When you can become a scammer and do quite well.
You basically think it's a moralistic point, Denny?
I beg your pardon?
It's a moralistic issue.
Which is to say, it's a spiritual. Why should you not be able? Why should you not steal? Why should you not lie? Well, if today they say, well, you've got to get ahead. That's why. If you, as you mentioned, Ian, if you don't accept lying and stealing, then you'll be canceled basically nowadays, and so you better do it. And so I don't see the CNPS as making much of a very big correction to what's happening today, because what's happening today is a corollary of the decline of people believing, for example, in the Ten Commandments, a religion, which is a religion, part of a religion. You have to, when you have a problem, you have to address the root cause in order to solve it. But nowadays, as Roger mentioned, people say, well, I don't understand the triune God and so on. Well, the point is, no one really understands it, but if you follow the Ten Commandments and in a civilization, your science and so on progresses, and technology progresses, and things get easier in many ways. Whereas if you don't, we have what we have now, scammers everywhere, the best universities teaching nonsense. So it's a matter of sort of by their fruits you shall know them. It's, as I say, a spiritual or moralistic matter, but I prefer spiritual because that's even gets at the point more clearly.
I mean, there are certainly problems in today's world. They're manifest, and you've intimated that they're so. But I mean, we've always had problems. We've always had people behaving badly. We've always had people lying and not accepting, moralistic or spiritual points, if you wish, that one should be concerned about behaving correctly and the welfare of one's fellow man and so on. And I suppose previous societies, benefited liars and people who were involved in scams. It was just there were different types of scams. We just now have a very highly technological society. And
yes, but in the old days, science would progress, things would get easier, scammers wouldn't spread to everywhere, and especially on the internet nowadays. But as you mentioned, there's scammers before the internet.
Yeah.
But
I was going to say that
there was advancement in the old days. Now it's regression.
Yeah, in many senses it is. And we certainly have tools, magical tools, to propagate any sort of nonsense. And people are very credulous now. Oh, I saw that on the internet, so it must be correct.
Yeah.
Or I saw that on the media, so it must be correct. And the authorities, the politicians or the media have told me that this is so. And they say they have the scientists at their back. whether you mentioned climate change earlier, or one could even be more controversial and talk about vaccination or so. All these views are formed by the information highway consensus, if I may just coin a few words there. That's where I think it's like it's a new orthodoxy, which you daren't question. You question it at your peril, as I think you suggested earlier, Danny.
Yeah. Well, there was a time in this country when you could speak your mind and not be canceled. And things, so this country progressed. Now you can't, and so this country is regressing.
Yeah, and I suppose frequently it was said, maybe earlier in the earlier century or whatever, that the US was a beacon of light because you could have oppressed peoples from other parts of the world or something going there and saying what they like and so on. And maybe in that sense, there's been a very great regression. I mean, it's not just in the United States, but that's very clear to us. Very clear to us what's happening there. And unfortunately, I say that the world copies a lot of your bad examples. So this whole cancellation business, which you referred to a number of times, it may have originated in the United States and it's being copied everywhere. In my country now, it's the top thing to do. You must cancel people, and you must take offense. If you hear another person express a view, you say, "I'm offended by your view, so you better shut up, or I'll take an action against you."
Yeah.
This is the sort of, no free speech.
But
Roger,
that started out not in the United States. That started out in communist countries. It was communism invented cancellation.
Yeah, that's probably true. Yeah, that's true. And I noticed that in the communist countries, and we said we were in the free West, and now it's been adopted with a vengeance. It's disguised. It's not. They don't say, "Well, I'm Stalinist." They just say, "I'm woke" or something. It's the new. Just put different words on it. It's very Orwellian. Well, what do you think, Roger, about all this?
With me, when this internet thing first started, it was supposed to be a platform for free speech, and then further on down the line, we've got down to the problem where people start wanting censorship. So people have sort of like realised that they don't want to really listen to people with other points of view to themselves, and so hence censor it. But that wasn't what they knew at the time. Whenever the internet started, was it 20 years ago? It's sort of like, people believed, we can all talk to other people would have different points of view, can talk to one another. And now further on down the line, we've sort of like realised, no, we don't want to listen to other people with other points of view. We want to censor them. And that's when all the banning is going on. So freedom of speech doesn't seem to really work. It's sort of like, it was nice to believe in it, but when you get down to it, freedom of speech only goes down to, only want to hear things that agree with me. I don't want to hear people having different radically different points of view. And that's what people suddenly found out. But back onto the issue of relativity, you were talking about scams. It seems like it's been a massive scam, and it's been going on for nearly 100 years now. They've managed to say that experiments agree with relativity, and then
or over 100 years, yes.
They've expected people just to accept that experiments have shown relativity to be true, and then they say you should believe it because of that, even though it doesn't make sense to you. And they've managed to get away with it for ages. If it's a scam, it's been going on for a very long time. Critical thinking.
If that's so, it's quite amazing because other false philosophies, if you like, we would say, have not existed for as long. I mean, like this Marxism or something, that believing that was the ultimate infallible doctrine, that only lasted 70 years. So this physical science outlasted it.
There's still people who are Marxists. And I've argued with these people.
Yeah, no, I mean the doctrine that Marxism, Leninism was 100% correct, and everything else was in error. Like as if it were a new religion. Well, say in the Soviet Union or maybe in China.
I've argued with those people. I've argued with them.
That died down. People still believe in Marxism.
I've argued with them and say, well, it's never worked.
Anyway,
it's never worked. You tried it. It's never worked. But then their argument back is it's never been tried properly. So you've got to try it again.
Well, that was the argument about Christianity as well.
Yeah.
That it's not that it was impractical and cast aside. It's never been tried. That's
so you can't really get through. When they accept Marxism has never worked, they say, well, it hasn't been tried properly, and we should try it again and get it to work properly next time. So there's no way of convincing a person who's fully Marxist to change their mind. And it's similar, I think, with relativity, Einstein's relativity. People that have been taught it and they've decided to believe it, that then firmly wedged into their way of thinking about things. And they just
if they hold it in such an absolute way, and you point out some ostensible error in it, well, then they will. You call it moving on. What they will do is they will say, yes, but that's not true Einsteinian relativity. You don't understand it. You have to. It's like it's not true Marxism or it's not true Christianity. When something bad comes of the.
They move the goalposts.
Yeah. You
call it the theory is flexible enough that they can add something extra to it.
Well, you can add something extra, like an ad hoc hypothesis, to try to explain something which seems to contradict the hypothesis. But what I'm talking about is apparent Einsteinian relativity is against true Einsteinian relativity. True Einsteinian relativity must, by definition, be 100% correct. And if you show any incompatibility, well, then you're not understanding it properly. It's like a reinterpretation.
Yeah.
So,
but
Danny,
as I pointed out, they've been teaching for a long time that there's relativistic mass, but now suddenly some of them changed their mind and saying there isn't. And they sort of like, well, it should be an admission that it's a different theory, but they don't. They just pretend it's the same theory, and they say, so a person says relativity is so. You point out to them, well, somebody else is saying relativity is something else, and the person you point that out to will just say, well, those people didn't understand relativity properly. So you can't win. Yeah,
I know. I mean, here's a comment pointing out
they're
that
fully locked into their beliefs.
The velocity business we talked about, constant velocity. Dowdy shows a solution that uses classical mechanics in ordinary Euclidean space with C plus V signal. He says Dowdy is right, Martinez. Now, I'm not sure. Kev Kahn came back and he said he was disproved or something. No, sorry. Don't know who he's referring to.
I think it's private conversation, that one.
Yeah, but I think it was interesting because it's referring to some things we've been talking about because he was shown to be wrong. I'm not sure whom Kev is referring to. Might like to come back about that. Make comment. So, Danny, is that all for the present? Thank you very much for raising all those points.
Thank you for listening.
I think one of the points about the morals, I think part of the problem has been Einstein's relativity, because Einstein's relativity leads to the idea of relativism, and relativism is the belief of other people's beliefs. And I look out for the term relativism, and I noticed it being mentioned in this latest film out called Conclave, when it's the film about the people in the Vatican and they're voting for the new Pope, and they were split between those tradition. Can you put the light on, please, Ange? I have not been able to get the light switch. So
yeah, you're in the dark. So I hope not.
So in this film, you've got the traditionalists, and you've got the people who are progressives, and the progressives seem to be the ones that believe in relativism, and the traditionalists are saying, no, let's stop doing all this. You can see me now. Let's stop all this relativism. Yeah. And I blame Einstein.
Okay. Well, that's one aspect which might have helped this to rise in the last century. However, what amazes me is you can find a communist, extreme communist Marxist physicist. You could find a Western atheist who thinks religion is not nonsense. You could find a very, very religious physicist who's accredited in the Vatican. He might be in the Vatican Observatory. They all believe the special theory of relativity. It's not as simple as that divide. It's so all-embracing.
Well, the Catholic Church has had its big ecumenical meetings, and some of them have gone on, I think, this idea of being progressives, and they are changing their fundamental Catholic beliefs. You've got the traditionalists who want to stick to things as they are, and you've got those who want to change things a bit. And so this film Conclave did emphasize this, where when it was voting for the Pope, you're going to have a progressive or a traditionalist. And part of the problem that I saw is relativism, where relativism is not supposed to be part of Einstein's relativity. But if you believe in Einstein's relativity, there's a tendency to believe in this philosophy of relativism. And that has influenced our world. But I think I've lost my track now. It's sort of like
I think you were describing very well what sometimes has happened in the West. They say, this is relativism. We're not dogmatizing and talking about absolute truth. It's freedom and so on. But the amazing thing that I'm pointing out is that it hasn't been used as a weapon between different ideologies. Like, say, during the Cold War, the two groups which were almost going to blow up the world, they were at each other's throats. They both totally would have had the same view. The established academics in Soviet Russia and this established academics in the United States of America, they would have had the same view
about relativity.
So,
Einstein's relativity has been promoted a lot. It's sort of like it's supposed to be. One of the ways they get it.
I will say that I think I've seen in very recent years, maybe the last 10 or 20 years, that's recent to me, a little more tolerance or a little more possibility of looking at this thing. I think maybe in the 50s, 60s, 70s, it was probably worse, Denny. I know you talked about cancellation and losing your job and all that sort of thing. I think that was worse. I think if you said something in what you would consider might have been freer times, say 50 years ago or 60 years ago in the United States or Western Europe, I think there was less tolerance of criticizing maybe special relativity and the basic theories of modern physics than there is today. I think there's a bit of a chink of light there.
Well, the theories get old, and it gets harder and harder with technological advance to hold to a wrong theory. And so I think you're right. Things are loosening up a little bit, but still, if I guarantee if you're a physicist and you start talking against special relativity, if you're a physicist at a university, a professor or something, they'll get rid of you. So what you have is a little loosening up, but not really enough to preserve your job if you step out too far out of line. And
I think we're agreed on that, Danny. So maybe if we can leave it at that at the present, you've raised very interesting points related to why maybe a lot of this is accepted. And if we can leave it at that, I'm not sure. Thank you very much, Danny.
You're welcome.
Thank you for raising that. I'm not sure. I noticed that Harry is here now. I'm not sure if Harry wants to say anything because there's an opportunity maybe just to bring one more person in. Okay, he does. Okay.
Okay, good morning.
Hello,
I'm
Harry.
not sure if it's working well.
It is working. It is working. Yes.
Okay, good. I've got a new computer. Got a different computer.
Sorry, Harry. There's a delay.
There's a delay.
When I speak, I can hear my voice coming back. Roger. I don't know if you can fix that.
All right, Mike, I have a comment here. I think we've established that relativity is religion and not science. That seems to me pretty clear. The question is, what about their religion that's incorrect? So they have a theology, and you've talked about a book that is like a Bible. It's a theology of relativity, and yeah, that's a theology. That's like people who publish books on theology that discuss what Christian religion means and interpret it. But my question is, my concern is, realizing that it's a theology, okay, and realizing that what they're doing is they're rationalizing the discrepancies in their theology. The real question is, where are the discrepancies and how can they be fixed? And in my view, the postulates are incorrect, both the relativity postulate and the light speed postulate are incorrect. And one of the ways that you can determine that is asking people what they think the postulate is, and what you'll find out is you'll get a lot of different answers. And the answers contradict each other. Particularly the light postulate is a big problem. What does the light postulate mean? Does anybody know? Well, what is it? If you look at one book, they'll give you one postulate. If you look at Einstein's 1905 paper, it'll give you a different postulate. So what's the light postulate? What is the light postulate? Can anybody tell me what the correct statement is for the light postulate?
Do you see? There is an echo. It's very hard to speak. But
okay,
the expression of the second postulate, if you take the words, are actually correct. The words are correct. The speed of light is independent of the speed of the score. That's what it actually says. Now, what they've done later on is
excuse me, Ian. I don't think that's correct. A lot of people, that's where, I don't think that's correct, what you just said. I don't think that's correct. The speed of light is independent. No, that's, a lot of people don't believe that. And we've had discussions, email discussions recently, where Cornelius asserted a different form of the postulate, which said nothing about the independent of the source.
Yeah, indeed. That's the way that it's normally expressed now. And indeed, even at the end of Einstein's paper, it seems to say it's independent of motion of either. But in the first page of the paper, it actually says those words, independent of the source. Velocity, it says. Now, that
he gives two definitions, and then in later papers he gives completely different definitions. So which of the definitions is the correct one?
That's right.
What definition does Rendler give? What does Rendler say in his book?
Have a look at that, Roger.
What does Rendler say?
He says it's independent in all cases. I think what Cornelius has been on. I'm the first to say that's erroneous.
I'm not sure what that means. What are you holding up there, Roger?
There's too much
Roger,
echo
going
on.
Yeah, there's a ton of
I can't follow it. It's too much echo.
It's going back to
All right, so the system's not working. All right, so I'm going to sign off here. We can't really have a conversation. Whatever's going on is not working correctly.
Okay, thank you.
All right, thank you.
Thank you. Yeah, that was a little different.
Sorry about that. It's too much echo.
Working, but it was working too well. It was getting echoes of everything we say, delayed, so we just couldn't hear what each other was saying. But to make absolutely clear what I'm saying, because you can think about this, and you can come back to me about it if you wish, is I quite accept that the way it's been interpreted is that there's a reciprocity between source and observer motion. It's only the relative speed that's important. in special relativity. That's the way it's interpreted in all the textbooks. I dare say in Rindler's book as well, as far as I remember. You can tell me if this is correct or not. That's the way it's interpreted. That's correct. However, if you take out the first page of Einstein's, or maybe it's the second page, 1905 paper on the electrodynamics of moving bodies, as actually Halem has said here many times, it's not about relativity per se, but if you take it out, he says we'll elevate these to postulates. And the second postulate is that the speed of light is independent of the speed of the source. That's quite different from the more general statement. And as far as I'm concerned, that's actually a correct statement if you took that in isolation. So let's see, the time is catching up on us now, Roger.
Yeah. So what Einstein says in his paper,
what do you think about that?
I've looked at that lots of times, and that's difficult to understand as well. There's problems in it being translated incorrectly, and then I've read papers where they point out that what Einstein said, they've actually changed it. The light's constancy, light's being made such thing in this paper, and later on they've decided it means something else. So there's been changes. It's been progressive. So going back to his paper, there's problems in understanding it, and then they've made changes.
Quite so. And dare we say, to add to that, Roger, that on the second page that I'm referring to, or something of this 1905 paper, Einstein has C plus V and C minus V in working out the equations and time difference, which are basically not acceptable in terms of special relativity. There's no such thing. So so again, Hallam is saying Einstein was confused. So that may be the thing. But what he said initially is not exactly the same as it seems to come out generally. And I think this is your thesis as well, Roger.
Yeah.
So
that's one of the ways. So it depends on who you talk to, but people that believe in relativity, some of them take the point of view that Einstein was confused about things, and then they put their own interpretation onto it.
Others might be more charitable and say, well, there was an evolution.
Yeah.
I see there's one more person.
Einstein's thoughts were changing. He started with special relativity in 1905, and he was trying to bring gravity into that. And he had a halfway theory, a partially formed theory, about 1913 or something. And then he came out with general relativity in 1915, 1916. And he was still working on... I don't have a
problem with that. But the problem is that it is, and I think maybe this is your point as well, Roger, it is frequently put as if it's a consistent evolution from 1905 to 1915, and there are no ascents and descents on the way and verification.
But the problem is Einstein, 1905 to 1915, he was changing his mind on things, and he wasn't really saying why he changed his mind. A lot of the time, you'd say one thing, and later you think about it, and you say something different. But he hadn't gone into explanation of why he decided to change it.
I mean, Jim says maybe Einstein was just the front man for the scam. I mean, I don't know if it's so well organized, that they've done that. But one does have to wonder. Now, I do have something else to do before we close. And I noticed there's one person in the green room who hasn't addressed us. He says it says the devices are not connected. It's Carl Reef. So, Carl, before we close off in a couple of minutes, if you want to come in, you're welcome. He's not connected. He's logged into the green room, but he's not connected. And
okay, so we're still having lots of problems with StreamYard.
Well, we are, and I know we're having offline discussions about these things, and I for one,
on Zoom, I've no problems.
Have kept
Zoom
this
doesn't
other
give me any problems.
Yeah, I know. For my talks,
it's unbelievable. I don't understand it.
But I think the only problem, actually, that I can see is not Carl's device not being connected. I mean, that's a physical thing. But the problem that Harry seemed to have solved his non-access by using a different computer or whatever. But we're getting this echo. I don't know why that'll be intolerable.
I
Anyway,
don't know.
I'll give you an opportunity of coming back and summarizing, Roger. But if
Yeah.
you'll permit me to do, and I'm actually just looking to see if anything else coming in. Okay. I'll just impose upon everybody. Let me just see, can I find it now? To play just this very short video, which has been recorded by David DeHilster, the president of the CNPS. And this is sort of a repeat of an earlier fundraiser endeavor, which we had last year. And he has given reasons why the fees that are obtained from membership, which are very much appreciated, are not covering the costs. We're going a far way in now making up a shortfall, at least for the coming year. So I'll just play David's little video now.
Hello, everyone. I'm David D. Hilster, president of the John Chappell Natural Philosophy Society.
Or do I have to do something? I'm not sure now.
Hello, everyone. I'm David D. Hilster, president of the John Chappell Natural Philosophy Society. During the past 2 years, we have used annual fundraising drives in order to keep our organization's presence alive and well on the internet. Both years we have been successful in that the monies collected have been enough to keep us afloat. This year is our third annual online fundraiser, and once again we are counting on your support. But first, I want to thank everyone who pays their annual memberships through our automatic online system. Your support is vital and provides us with important funds to keep the CNPS afloat. Hopefully, as we continue to grow, we will be gaining more and more automatic memberships so that these fundraising events won't be necessary. But we are not quite there yet. This year, we will be implementing several changes to our online system, several to save money and lower our annual expenses, and another to better our discussion platform. First, we will be moving our websites and databases to another server that has graciously volunteered to host us at a much reduced rate. It currently costs us $1,400 a year for our dedicated server, given that we need complete control over our own software. The new server will give us and allow us that control, but only for $250 a year. Second, we will be moving away from BuddyPress, which is a Facebook-like plugin for WordPress, to using Discourse. BuddyPress was an interesting experiment, but the upkeep of the plugin and its general design don't really fit what we need. What we need is a robust and well-accepted discussion forum, and that is why we'll be moving our online discussions to Discourse. It costs $20 a month, which is half the price of BuddyPress. I think those currently active in our online discussions will find this new platform much more enjoyable and functional. Third, we are moving to a free version of Overleaf, which eliminates a $33 monthly fee. Overleaf was useful for us when we were publishing our own proceedings for conferences, but that is no longer needed. Our goal this year is $2,000, and I hope we can reach that goal. Whatever amount you can donate, it is greatly appreciated and needed. Your membership and donations are vital to keeping our online community of critical thinkers alive and well. To donate, go to fund.naturalphilosophy.org. That is fund, fund.naturalphilosophy.org. Thank you, and keep up the amazing work that is driving science forward.
Thank you very much. Now, what I'm going to do, we have a few minutes left, and I'm going to give Roger the opportunity of maybe just summarizing the situation insofar as, we've demonstrated it today. I must say that you've prompted a lot of responses looking at this whole subject from various angles. And I think it's been very useful to have one of the sessions, personally, the sessions that I moderate, dealing with this. And thank you for coming along to one of my sessions to do that, Roger, because I know you've recorded a lot on these sort of issues on YouTube. I think that there's a lot of information out there which we need to address, particularly in regard to some of the points that have been raised by Denny and even Harry in the short period he was there, and also, of course, Jim. So, Roger, I'm going to go down. I'm going to give you the complete floor for as long as you want, a minute or two or whatever, to address these points. And in the light of some of the comments that have come in and some of the discussions, which unfortunately we haven't had enough time to go into in great detail, but I hope we'll come back to. So, Roger, the floor is yours again, finally.
Hi. Hello. So this book, which you can see reversed, it says Introduction to Special Relativity. And it's supposed to be an easy to understand introduction to the subject of special relativity. But just starting off, it's sort of like it's making all these outlandish claims and it's not giving sufficient information to back up those claims. It's just not making sense. And that's even before you get to the theory proper on when it's supposed to be stating the postulates. So it's just building and building and building more and more stuff, doesn't make any sense, and just keeps building upon that. And when it gets to the postulates of special relativity, it gets just worse. And so the mainstream, with their education system, have just seemed to get away with being able to teach nonsense to students. And the students will either they just have to accept what they're told and regurgitate it all again back in the exams for when they're tested, or just give up on the subject. And so that the mainstream physics has made a terrible mess of things. They have not really addressed the problem of trying to give education on special relativity in a consistent way. It's just mainstream physics has just failed, in my view. Thank you. So we can close down now.
Okay. Well, I'll officially close down. So you're still there in the background. Thank you very much, Roger.
Yeah. Thank you. Cheers.
Thank you. Yeah. Well. I'm delighted for my part that Roger came along to one of my sessions today to express his position on relativity and relativity lessons and so on. And it certainly spurred a lot of consideration, tangential consideration with regard to sociological aspects, psychological aspects, political aspects, religious aspects, whatever you wish. And I think, if I may say so, that what's occurred to me anyway, and I'm going to give this more thought, is that there is a distinction between the more classical deductive system and what's come in nowadays. And I know we were talking about cancellation and conformity to general views put out in the internet and all this sort of thing. But I mean, you have the classical system in, say, Euclidean geometry, where you might prove some proposition by reductio ad absurdum. You might assume the contrary and then find that it results in an absurdity. So therefore, you've proved that is not the case, and therefore the contrary is the case. Now, it would appear on the face of it, if I may say so, that something like the twin paradox, or the question of simultaneity at the same time as non-simultaneity. So in other words, or synchronicity, I mean, symmetry, I mean symmetry, the same between observer and observed. Well, it's source and observer, if you like. So, for example, the twin paradox would be an example of that, where the traveling twin, his clock runs slower, but also the other guy does as well. So how do you now in classical logistics, that would be considered sufficient to disprove the thesis. But no, we just introduce new interpretations or hypotheses. And this is what Roger has been going on about. And something, quite a respected text among the conservative academic milieu would be Rindler's text. And Roger has taken this task and just taken the statements and analyzed them and, indicated how maybe they're not quite everything. As regards the proposition that we should maybe start finding that there's an incentive to teach anything other than this orthodoxy, that's a difficult question. Maybe by bringing in some other ideas. Jim is going to be talking to us on binary mechanics further, so it might be an opportunity for us to rehearse this a bit. But also, in regard to Halem, who'll be discussing with us, Professor Halem, in the new year as well, some of his ideas, which are not very far away from, dare I say it, my own ideas or Denny's ideas, which we discussed earlier on. I was actually quite interested how it appears that there is some link up between Roger's analyses of, the phenomena and how maybe they don't quite fit the light of day, and some of the analytical approaches that I and others have been involved in. So, for that alone, it's been well worth having this interactive conversation. And I think the talk today actually has been quite as interactive as any that we've had in the past. So I'd like to thank all of you for having come today. It's not a very big attendance, I can say, actually, from the comments coming in, and it's probably because of the season. And in the green room as well, it may be slightly smaller than usual. I think it's probably the season. But I'd like to thank you all for coming here today, and all of you for making your points. They're all very, very well taken. There's been some conversation that maybe I haven't got to as usual, but I apologize for that. And thank you for everybody in the green room for coming. I'm sorry about Harry's problems again, the audio, but thank you everybody for your contributions. And of course, last but not least, thanks to Roger, because Roger is actually very prolific. He produced a lot of these videos and, the slides and his analyses and so on. And we mightn't always be cognizant of what he's actually putting out there in the ether, if I may use that propitious word. So this has concentrated our mind that he's talked about this lesson 1, and there might even be a lesson 2, actually, I think somewhere out there that we might come back to, and it's got us thinking. So we'd value your input. So all that remains for me is to thank you very much for your participation, particularly during this year, because I think, this is the last of my sessions for this year. You'll probably have to bear me a little more, but not till January. And all that remains for me is to thank all of our participants and all of our speakers, to wish them a very Merry Christmas and a Happy New Year. Goodbye.